Assalamu alaikum. Now, Taha, let me explain you this question which you have asked on complex numbers. Let me read the question first. Solve the equation z square minus 2p iota z minus q is equals to 0, where p and q are real constants. So if we look into this equation, this is quadratic in z. So whenever any equation is quadratic in any variable and we want to solve it, we have only one method which is called quadratic formula. So try to identify what are the coefficients of the z square. So I call it as a, and it is here 1. The coefficient of b in this equation is minus 2 p iota, and the constant is negative q. And the equation is quadratic in z. Now, as per quadratic formula, it should be equals to minus b plus minus b squared minus 4ac whole over 2a. Substitute the constants a, b, c's into the formula. So minus 2p iota plus minus 2p iota whole squared minus 4a c minus q divided by 2 and 1. Now try to simplify. This expression will finally come to us as 2p iota plus minus. Now this minus will be absorbed by this squared, so minus gone. 2 square is 4. The square of p is p squared, and iota square is minus, so I'm going to write this minus at the back of 4p squared. Minus 4p multiplied with minus q gives you plus 4q divided by 2. Now, can we simplify our expression which is inside the radical sign? Can I take the square root of, within the square root 4 is common. When I take it common, and then it will come outside of the radical sign and looks like 2, because the square root of 4 is 2. Inside the bracket, I'm going to write q first and then p squared. So q minus p squared will be the remaining thing we have in the bracket. Okay, so now can we take or factorize to cancel out 2's? Finally, we will get p iota plus minus square root of q minus p squared. So what are the roots? z1 is equals to p plus, sorry, q minus p squared plus p iota. This is my first root, and my second root is minus square root of q minus p squared plus p iota. Let me highlight the roots which we have found. Now read the instructions of the second part. He said that in the Argand diagram with the region O, the roots of this equation are represented by the distinct points A and B. Given that A and B are on the imaginary axis, yani y-axis, find the relationship between A and B. So Taha, we need to use this condition which is given by the examiner, that A and B are on the imaginary axis. Suppose I have Z1, which is q minus p squared plus p iota, when I write it as a point on the Argand diagram, so it will have a x coordinate as q minus p square, or real part, and imaginary part is p. And complex number 2, z2, which is minus q minus p squared plus p iota, when I write it as a point on the Argand diagram, its x coordinate or real part would be q minus p squared and p. Now I'm going to show both of the points on the Argand diagram. So on the Argand diagram, guys, this is a real part of the z, and this is imaginary axis for the complex numbers. Suppose this is point A, whose x coordinate is square root of q minus p square. It is a positive number, that's why I have shown it in the first quadrant, and p is also here. So I assume that p and is a positive number, that's why the placement of the complex numbers are like this. And then I have to take the negative value of square root of q minus p squared, and this is your point p. Clear? He said that these points A and B, which I have shown, imaginary A and B are on the imaginary axis. If it is imaginary, so then it means the x coordinate should be 0. Or there is another thing. I must have said that this expression, which is under the radical sign, has to be negative. So q minus p square has to be less than 0. Then I will get my answer, um, you know, in the form of imaginary unit, not as a real part. So what I'm gonna do, guys, q less than p squared. So this relationship establishes the the movement of your two complex numbers on the Argand diagram. They will be shifted to the on the imaginary axis. So q has to be less than p squared, right? So maybe this Argand diagram will be helpful for me for the C part if he simply says that Q and P are the numbers and there is no condition that A and B are on imaginary axis. So let's go to the C part. The same thing happens which I have said. OA given instead, OABC is an equilateral triangle. So is it possible for us to complete the Argand diagram again? In the previous part, it was not very helpful because both of the roots were shown on the imaginary axis. So this is your imaginary axis, and this is my real axis. This is A point, q minus p squared comma p, and this is my B point minus q minus p squared p, and this is the origin. Now, as per the examiner, I want to prove that this triangle is an equilateral triangle. Now, as per geometry, equilateral triangle, any condition can be used by by the student to show it to the examiner that this is an equilateral triangle. So, boys, this is clear that this, uh, this length is 2 square root of q minus p squared, and this length can be easily found out by using Pythagorean. So OA length, this is p, this is square root of q minus p squared. Let me apply the Pythagorean. Hypotenuse is equals to the opposite squared, square root of q minus p squared plus p squared. Square cancel with the square root, I get p minus q squared plus p squared. Wow. So I got my answer square root of q. So every length has to be equals to square root of q. Now the condition is given that I know that this OA length is the same as OB length, and it should be the same as AB length. So it helps us to establish the relationship between Q and P. So let me put my side AB equals to OA. So OB is 2 square root of Q minus P squared, and whereas OA is square root of Q. Can I take the square on both sides? It will help me to write my expression in this form. Now open the brackets, 4q minus 4p squared is equals to q. Then 4q minus q is equals to 4p squared. Then 3q is equal to 4p squared. Imagine, guys, I found a relationship between p and q which ensures that when I plot these roots, which are represented by points A and B on the Ergen diagram, and when I complete a triangle by joining AB points with O, it will make an equilateral triangle. And if I want equilateral triangle, I have to select the Q as 4/3 of the square of the P. Then this condition will be satisfied. Thank you, boys. I think this complex numbers, which was totally based on equations and the geometry of complex numbers, is very, very important for the final exams. Assalamu alaikum wa rahmatullahi.